Okay, so we've been talking a lot about electrical. We're going to talk more about control systems now, because there's a lot of changes in the way we're controlling things, and there's been a lot of changes lately in the protocols and the way we're running shows. So lately we've been doing a lot of networking in our industry. And why is that? Why do we need to network stuff? And the reason is that the channel count is growing. It's a virtual explosion in the number of channels. I mean, if you look at this rig, there's all kinds of pixels like this. And every one of these has red, green, blue. And you notice that they also have the ability to individually map a graphic onto this display. So if you look at this, there's 1, 2, 3, 4, 5 by 5. There's 25 pixels here. Every one of those has red, green, blue. And then you probably need to control the intensity separately from the color. So that's 4 channels times 25. There's already 100 channels right there. So 100 channels 25 years ago in our industry, that's crazy. We used to have lights that had maybe 6 or 7 or 8 channels. And then it became 16 and 18 or 24 or 32 channels. Now we have lights that have 68 pixels on the front and red, green, blue. You add them all up with pan tilt and intensity, and then it ends up being 250 channels or 240 channels. So that's half a universe of DMX. So how do you control that? How do you put together a show like this with all of these different parameters? Well, you do it with computers, basically, which means that the abilities, our capabilities are increasing, but also the complexity is increasing as well. If you think about the way the industry evolved, it used to be that a lot of our lights were analog. Even the early moving lights, the first moving lights I ever saw were these golden scans, and they had 7 parameters. And there were analog controls. So that meant you had to have one cable going to every fixture. Now imagine this rig right here, where you had to have one control cable from the console going to every fixture. That would be a nightmare, wouldn't it? You'd have cables everywhere. That wouldn't work very well. So what happened was in 1986, they introduced DMX. DMX is digital multiplexing, DMX. And that gave us the ability, instead of having to run one cable to every fixture, now you could run one cable from the console to the first fixture. That's called the home run. And then you can daisy chain the signal to all of the fixtures in a row. It's much better cable management. And then over time what happened was our system started getting bigger. A system like this is a nice size system. So think about how many individual attributes are under control here, and I'm guessing you've easily gone beyond the 512 channel count of a single universe of DMX. So we end up with multiple universes of DMX, and if you use the old way of controlling things, that meant you had a whole bunch of home runs. Well, that doesn't work too well. So what ended up happening is we started moving over to more networked systems. So that allowed us to do really complex shows. If you think about the kinds of shows we're seeing today, this is the 2012 Olympics in London, and they pixel mapped the entire arena. You can see they're pixel mapping red, white, and blue onto the seating area. And to do that, they needed 70,500 pixel tablets. And a pixel tablet is a 3x3 array of LEDs that looks like this. So each one of those pixels was in one seat. And of course, every pixel has the ability to change color, red, green, blue, and the intensity. And that's how you can take video and map it to the seating like that. So you have 70,500 pixels. That's a total of 634,000 pixels. It took 370 kilometers of power and data cable, 58 Barco controllers, those are video controllers, and 450 video hubs, that's data distribution. It took 3,400 video converters, 15 kilometers of battery-powered LEDs, 28 projectors that were 21K ANSI lumens. They used 29 media servers of the Avo Lights variety, and then 10 Catalyst media servers plus 10 backups. So it's just a tremendous system that would be impossible to control if you didn't have the networking capability that we use today. So as a result, we've ended up with all different sorts of control, proprietary control protocols. Every manufacturer almost now has a proprietary protocol that they use to control systems, and they're all basically the same thing. They're using an Ethernet-based protocol, so they can use Ethernet networks to transmit multiple universes of DMX. You know what Ethernet is? That's just the kind of network that you use in your office that we used to use at home. Now we're all Wi-Fi, right? We're all wireless. But it used to be that when you took an Ethernet cable and you plugged it in, you plugged it into an Ethernet network. And that's what we do now with the vast majority of our control systems. So the whole hog, or actually the hedgehog controller back there is probably on a hog network, which is an Ethernet-based type network. It uses the same Ethernet cable. It uses the same Ethernet hub, or not hubs, but switches or router. Thank you. Uses the same switches and routers as every other Ethernet system. So as a result, here's what our current systems look like. We typically will have a controller that outputs an Ethernet-based protocol. The common Ethernet-based protocols today are ArtNet and streaming ACN. Those are the two most common that we'll use. And almost all the consoles now will output ArtNet or streaming ACN. And you may have seen the, oh, here's my eraser. You may have seen the little s, big ACN. That's the acronym for streaming ACN. That's a type of control protocol that comes from the console that carries all of those multiple universes of DMX on a single Cat5 cable or a single Ethernet cable. So the reason it can do that is because Ethernet networks are much faster than DMX. The baud rate, or the rate of transmission of DMX, is 250,000 bits per second, 250K baud. Ethernet, on the other hand, can go as fast as 40 gigabits per second. 40 gigabits per second. That's 4,000 times faster than DMX. 4,000 times faster than DMX. That's why we're using Ethernet-based network systems today. And almost every show of any size today will have some sort of Ethernet-based network between the console and the lights. If you're building a theater today, you wouldn't dream of building a theater without installing an Ethernet network, or fiber even. If you're building a church lighting system, same thing. You're going to put in either copper wire, Cat5 copper wire from the where the console is to the platform, or you're going to put in fiber optic cable from where the console is to the platform. And you'll probably also run it, for the cameras, for the switching. So everything is networked today. In the theater, in arenas, typically when you go in and do a big arena show, one of the things they do now is they will run fiber around the top of the arena. And then they'll tap off of that, and they'll have all these switches, and it might even be up in the catwalks too. You can have a ring of fiber in the catwalk, you can have a ring of fiber in the nosebleed seats, in the upper arena, upper bowl. Sometimes even on the floor of the arena, there's a ring of fiber going around. Because we're moving so much data today, you need that kind of bandwidth, you need that kind of speed to move it around and to use it, and to make the best use of it. So that's why we're using all of these networks today. Now let's talk about DMX. The current standard for DMX. Now remember, DMX is the lighting control protocol. The first DMX was only designed to control dimmers. Of course, we used it for moving lights, and then later on they changed it to lighting and accessories. So today they recognize, yeah, we're going to use it for a lot of things, not just lighting anymore. So it came out in 1986, and remember, in 1986, computers were very slow compared to today's computers. That's why the baud rate for DMX is only 250 kilobits per second. Not even mega, but kilobits, 1,000 bits per second. So, but you know what? It works just fine for our purposes, only because these lights don't need that much bandwidth. There's at most 250 parameters. So DMX works just fine for what we use it for. Now, we do have to use multiple universes, but again, we've kind of worked around that whole issue. So it came out in 1986, and it's a industry standard protocol. Today it's maintained by the Plaza organization. Plaza has a technical standards development program, the technical standards program, where volunteers from the industry come together and hammer out these industry standard protocols, these consensus protocols that everybody agrees this is how we should do it. And so that's who maintains DMX. So the current standard for DMX is actually DMX 512-A. That's the one that we use today. So it's DMX 512-A. So 512, that means there are 512 attributes under control, and the -A is the latest standard that allows the fixtures to send information back to the controller. So it used to be that we would just send information to the lighting fixtures or to the fog machine or to whatever, the media server, and we would just assume that it got it. But now we can query, we can ask questions of the devices we have plugged in. We can say, are there any error messages? Or what's your current DMX address? Or what mode are you set to right now? Or what version software do you have? So if you have a rig like this, and if you have a controller that can handle RDM, all these fixtures can, you can ask them, what software do you have? So you can ask all of the platinum beam fixtures, what's your software version? And you might find one or two that have an old software version. So now you know, oh, we've got to take care of that. Or, something along those lines. So DMX 512-A allows that to happen. Now you have to have the RDM, and we'll talk about RDM after a while, but you have to have the RDM protocol in order to do that as well. All right, so we're setting up our control system, and typically what will happen is we have our controller at front of house, and sometimes we will output from that into a protocol converter. A lot of times you have to have the processor that outputs the DMX signal. So you're going to go from the console into this box, and the box then is going to send DMX, or it could send ArtNet or some other Ethernet-based protocol like streaming ACN. And then back where the lights are, we'll have another box that takes that Ethernet protocol, converts it back to DMX for the end of the connection. So we're always going to, today we're going to go DMX into the lights. Now that could change because there are now lights that take ACN directly into the fixture, and then inside the fixture it converts it to DMX. So, but most of the time we're going to be plugging in DMX cables, the 5-pin or the 3-pin cables. They look like microphone cables, but they're not. We're going to plug those into the fixtures, and then we'll daisy chain to all the fixtures. So that's typically the way we'll do it. Now there's certain rules or guidelines that we need to follow when we're setting up our DMX network. Okay, so for example, the first one is to terminate your data run. What does that mean? What that means is that when you have a bunch of fixtures, went too far. Sorry? Well, here, we can go to right here. So you have a bunch of fixtures that you run DMX into, and then you daisy chain. When you get to the last fixture in the run, you have this little data terminator you plug in, because you have an input and you have an output. So, yeah. So here's your input, here's your output. If this is the last one in line, we need to take that terminator plug and plug it in to terminate the data. Now that terminator is nothing magic about it. It's just a 120 ohm resistor that absorbs that signal and prevents it from bouncing back down the line. Because if we don't terminate it, we have an open connection, then what will happen is the signal comes up against that open connection, it hits it and bounces back. So now we have the outgoing signal and we have the return signal, and they mix up and it messes up the signal. Now, there are a lot of instances where people just don't terminate. You know, you might be able to get away with not terminating, but chances are that's going to cause problems at some point. You know, it could be 3 years, 5 years down the road, but at some point in your lighting career, you're going to have a system that's not behaving properly, and then you're going to have to start troubleshooting it. How do you troubleshoot? You narrow down the problem. Is the problem the controller? Is it the cable? Is it the fixture? Is it the data terminator? Well, if you get in the habit of terminating, that's one less thing that you've already eliminated. One thing you've already eliminated you don't have to worry about. Somebody posted on Facebook yesterday, just yesterday, I had all these fixtures and they started misbehaving. And the first thing that people started asking is your data run terminated? And the guy said no. And so that's why I always terminate my data runs, because that just eliminates one other thing that could be causing a problem. Yes, question.
Yeah, if you don't terminate, does it cause any kind of damage to the equipment?
No, it won't.
Show, right?
Right. If you don't terminate, it will not damage the equipment, but it could cause problems with the show.
Okay.
So get in the habit of using data terminators. Anytime you go to a show, anytime you're setting up a system, you should have a handful of terminators and terminate every single line. So that's one thing. And then a maximum of 32 loads on one link. What does that mean? Well, in this case, I've got 3 different data links. And I should put no more than 32 devices connected in a row. And so for example, I could have 32 moving lights on one data link. Or I could have 31 moving lights in a fog machine. Or if you're like me, 31 fog machines and a moving light. You know. But no more than 32 devices. Because what will happen is if you have too many devices on one data link, then it loads the signal down too much and it doesn't work well. So 32 devices. No Ys or parallel connections. If you have lights on this side and that side and you have one data cable, you're real tempted to cut it and splice it and split it off that way. Don't do that, because that creates an interface between two different impedances and it causes signal bounces all over the place and it degrades the signal. It doesn't work well. You know, we're talking about how do you build solid, dependable, reliable systems. This is how you do it. Follow these guidelines. A maximum of 1,000 feet. Now, if you have a big show in a big arena, then it's possible that you could have more than 1,000 feet of data cable. To me, that's an awful lot. You know, and I think that personally, if I'm running 1,000 feet of data cable, I will probably go to wireless DMX. There's lots of good wireless DMX solutions out there. And with today's technology, I think they're very reliable and they work very well. So personally, I have little or no problem with wireless. Now, again, there's a whole bunch of other guidelines that you use with wireless to make sure that it works properly. For example, I was in Australia doing a workshop, and there was one person in the class who was saying, when we started talking about wireless, he said, "Oh, I don't trust wireless, it doesn't work." And I started asking questions. Well, what kind of wireless are you using? How did you set it up? How far was the distance? And you know, when I got to that part, how long were you trying to transmit? He said it wasn't that far, it's only 900 meters. 900 meters? Well, Wi-Fi only goes 100 meters. You were trying to go 9 times as far as it can possibly go. And now there are ways to do that. If you use a directional antenna, you know, most antennas are omnidirectional, the signal goes everywhere. But you can buy parabolic antennas, or you know, antennas that focus the energy in a single direction. And if you can see the receiver, it's a line of sight. If you can see it, you can transmit it that far. So it can go over a mile. If it's building top to building top, or some, you know, bridge to whatever. So there are ways to get around that 300-foot limit or 100-meter limit. But you have to understand some things about how wireless technology works. So no more than 1,000 feet. And then do use data splitters or amplifiers for complex networks. So like a rig like this, I've got, you know, a stage right group, I've got a stage left group, I've got an upstage group, and I've got a downstage group. So I could run a single link all the way around and catch every fixture. I'd have cable running everywhere. A better idea would be use a data splitter, run one link to that group of fixtures, one link to that group, one to that group, one to that group. That way, if you have a problem, if a data cable goes bad, it's not going to bring down the entire show, it might bring down a few fixtures. The more you can break it up, the more reliability you've built into it. Yeah, question?
So if you have an 8-way opto splitter, you can put 32 on each one of those?
Exactly. If you have an 8-way data splitter, you can put 32 devices on every one of those 8 outputs. So every output regenerates the signal, and you start over with your length and your device count. That's what data splitters are for. And you know what? It's easier to troubleshoot that way. If you have a bad data cable, sometimes you can have a bad data cable right there, but it's that fixture over there that starts wigging out and flashing, because it's just funny that way. Yeah, question?
So what's the difference between an opto and an amplifier? Or does an opto have an amplifier built in it?
Okay, so the question is, what's the difference between an opto splitter and a data amplifier? Well, first of all, not all data splitters are opto-isolated. People commonly call them opto splitters, but there are data splitters that are not opto-isolated. An opto splitter is a term for a data splitter that is opto-isolated. And a data amplifier is one in, one out. All it does is amplify the signal. But all data splitters regenerate or they retransmit the signal again. They don't necessarily rebuild it, but they retransmit it. Now, some data splitters do rebuild the signal. And so though, if you have certain types of equipment that's older and has slower processors, if the timing gets off, then they don't work very well. So in those cases, you can use these tools to rebuild the timing of the data signal, and that cleans up a lot of these problems. So if you want to build the data terminator, it's real simple. Go down to Radio Shack, and you better hurry because they're going out of business. But you can buy a 120 ohm, 1 watt resistor, and you solder it between pins 2 and 3 on a male connector. And that's your data terminator. If you want to, you could put a second one on pins 4 and 5, because with DMX512A, some devices like the Avo Lights consoles actually use pins 4 and 5 for a second universe of DMX. Now, so I'm going to have to use the mic again, but in a lot of these classes and workshops I do, there's usually 1 or 2 people who say, you know what, I never terminate my data runs, I never have any problem. Or they say, oh, I always run, 36 devices per link or 40 devices per link, and I don't have any problem, So I created this what is it called, extra normal video to address that situation. So
be sure to terminate your data when you get to the last fixture in the run.
Dude, I've been doing this for a long time. This is my 3rd year as a stagehand, and I never terminate my data runs. I never have any problem. Besides, all of the automated lighting fixtures these days are self-terminating.
Really? Can you name one?
Well, no.
Actually, there's one. The ETC Revolution is self-terminating, and some dimmer racks have a switch to terminate it if it's the last device in the data run. But as far as I know, there are no other automated lights or devices that are self-terminating. Look kids, when you're building a data network, it's not about what you can get away with, it's about building solid, reliable systems that work day in and day out, today, tomorrow, and next year. If you know and follow the guidelines, you'll build systems that will work every time and everywhere, whether you're in the Arizona desert in August or in Toronto in February. They'll work on the North Pole, the South Pole, or on the equator. You might be able to get away without terminating data runs on small systems with few lights and short data runs. But the bigger the system is, the longer the data runs are, the more important it is that it's built correctly. Cutting corners is eventually going to cause failure. And when will it fail? At precisely the wrong time. It will fail right before the biggest queue in the biggest show you've ever worked on. And after all, it's your reputation that's on the line. If the systems you build work reliably, then you'll get a reputation for being a great tech. If you build a system that is unreliable, then don't be surprised if you don't get called back again.
But what if I don't have a data terminator?
If you don't have a data terminator, you can build one very easily. Just get an XLR connector and solder a 120 ohm, quarter-watt resistor between pins 2 and 3. You can also buy them from insert sponsor here.
Why did you just say that?
Say what?
Why did you just say, insert sponsor here?
Because we don't have any sponsors.
Oh.
But there are lots of ways to make sure your network is as reliable as you can possibly make it. You just need to know the guidelines. Okay, it's quiz time. What is 5Q plus 5Q?
Well, let's see. 10Q.
You're welcome.
Okay, thanks. So anyway, I was just trying to drive home the point that you can get away with not doing certain things, but you should get in the habit of building systems properly so they work properly. And that whole thing about self-terminating fixtures, I've heard that for years. People often would tell me, well, I don't terminate because all the fixtures now are self-terminating. And whenever somebody would say that to me, I'd ask them, I go, really, which fixtures are self-terminating? They go, well, I don't know, I just heard some of them were. Or somebody would say, oh, all the Verilights are self-terminating. So if they would say that, I would go to the Verilight website and I'd download the user manual and I'd show them the part that says, be sure to terminate your data runs. And so now, I will have to say this, things change, right? So last September, I was the projection designer on a production of Rent at Texas State University. And we were in tech rehearsals, and I was sitting in the house, next to the lighting designer, and the head electrician came up to me and he said, hey, you see those lights back there? He goes, watch them, they keep flickering. And so I'm looking at them, and sure enough, I could see them flickering. And he said, what do you think is causing that? And the first thing I thought of was, well, did you terminate your data runs? And so I asked him, he said, no, we didn't. He said, those fixtures are self-terminating. I go, no, they're not. And he's like, and the lighting designer turns to me and says, are you sure? And I go, and I kind of, had second thought, because I spoke really quick, and I'm like, well, let me double check. So I jump online, I download the manual. Sure enough, those fixtures are actually self-terminating. They're ETC D60s. And so 2 weeks later, I went to a trade show in London, and I saw the guys on the booth, and I asked them, I said, hey, when did you guys start self-terminating those fixtures? And he said, well, since we built that model, they've been self-terminating. I go, well, are all of your fixtures self-terminating? No, only those. Only those. Really? Okay, so now I have to look it up to see if they're self-terminating or not. I go, can't you put a little LED indicator saying it's self-terminated, you don't have to terminate it? He goes, well, that would be too complicated, cost too much money. Okay, well, can you put a sticker on it that says this is a self-terminating fixture? Because otherwise, how do you know? You just assume they're all self-terminating? That's a bad idea. So don't ever assume that a fixture is self-terminating. And you know what? There's no harm in terminating a self-terminating fixture. Because what happens is, you know, the way you build a self-terminating fixture is you have a XLR connector, and it's a certain type. It's made by Neutrik, and inside it has switching contacts. And you solder a 120 ohm resistor across pins 2 and 3, but when you plug in a cable, it opens the contacts and takes that resistor out of the circuit. So it unterminates. So if you have a self-terminating fixture and you terminate it, it's still terminated. So there's no harm in terminating a self-terminating fixture as opposed to not terminating a fixture that's not self-terminating. Yes?
So can that fail, and when you
Yes.
go to plug it in, it's terminated already?
Yeah.
And it won't send out?
Yeah, I'm sure there's a million ways it can fail, and that's probably one of them. Yes, I think so. And as the fixtures age, that may be an issue. So just get in the habit of doing these things. 32 devices, terminate the data run, you're good to go. Now, RDM is a relatively new protocol. It came out in 2006. So here we are, 2015. That was what, almost 9 years ago that it came out. Wow, time flies. I can't believe it's been that long. Or maybe it's 2008 that it came out. Anyway, it's been out for a few years. It's just now starting to gain traction. What is RDM? RDM, remote device management, is what allows a fixture to communicate with the controller. So the way it works is, if you have a fixture that does RDM, and I'm pretty sure all of these newer fixtures have RDM, and if you have a controller or some other device that does the RDM, handles RDM protocol, then what you can do is you can remotely control, you can change the settings on the fixture remotely. So instead of getting a ladder and climbing up to the menu display up here, I can have an iPad or an iPhone, and I can change the DMX address. I can change the mode of operation. I can look at the software version. I can do all that remotely. So it's safer that way because I'm not climbing a ladder. It saves time. So there's a lot of advantages to this. I was doing a show where recently, this was about a year ago, a little over a year ago, and it was in a big arena. And there were 24 vomitories around the arena, and every vomitory we set up a goalpost. That's 2 pipes with a crossbar and a bunch of lights on it. And my job was to run the crews that were setting them up. And we set them all up, plugged them in, turned them on, ran the data cable, and then as we were working that day, the programmer radioed me and said, "We've got a problem with 4 of the strobes are not firing. Everything else I have control of, but those 4 strobes are giving us problems. Go check them out." Okay, fine. So I go down, climb down the steps of the arena, go across the arena to the boneyard where we keep the ladders. I grab a ladder, walk back across the arena, climb the stairs, and go to climb the ladder up to the crossbar, and the ladder wouldn't reach the crossbar. So I had to climb up around the back of the crossbar, get my wrench, loosen the bolts, drop the crossbar down so I could then lean the ladder on it, climb up to the top of the ladder. And this is before I had my headlamp, so I had my flashlight in my mouth looking at the dip switch settings. I had my iPhone with the DMX address schedule on it. And I checked the DMX address, and we had taped them down, so I had to remove the tape and went through the whole thing. And so then, I had to check all 4, had to drop the crossbar on all 4, and all the DMX addresses settings checked out according to the DMX schedule that I had. So the next thing was, well, maybe it's a bad data cable. And luckily, we had run redundant cable. When we run data cable from the protocol converter, we run 2 cables. One's a spare, one's the one that we use. So I went around unplugging the cable and plugging in the spare cable, and they still wouldn't respond. And it literally took me an hour and a half to check 4 fixtures. And when I got finished, I didn't know what else to do. I radioed the console operator. I said, Henry, we've checked everything. Everything checks out. He goes, stand by. And he's, comes back a couple minutes later. He said, oh, my bad. I had the wrong address in the console. So, it took me an hour and a half. I didn't have anything better to do, so it was no big deal. But it would have been nice if we would have had, if those fixtures did RDM, and I had my iPhone, I could have turned on my iPhone. I could have sent the signal to the fixture, tell me what is your DMX address, and it would respond back, and it would tell me the DMX address, and I could have compared it to the DMX schedule to see if it was set correctly. And that would also tell me, if I get a response back, it tells me, A, the fixture is working, it's powered up, it's working. B, the data cable is good, because how else could I get the signal back if the data cable was bad? So I could have done, it took me an hour and a half, I could have done it in 5 minutes had I had RDM. So I think there's a lot of value in RDM, and it is gaining traction. Almost every fixture that's being manufactured today has RDM in it. Now, not all consoles do, but some of them do, but it's okay. I realized after a while, because for a while I was really on this this campaign to try to get manufacturers to put RDM in the controllers, in the consoles, but I realized fairly recently that really where we need access to RDM is not at the front of house where the console is, because the programmer has very limited time to set DMX addresses. Really, the electricians are the one who need access to RDM. So there need to be apps that they can tap into the network and configure the lights, reconfigure the lights, monitor the lights, so you can monitor the temperature, the current, the voltage, all that stuff using RDM if they have the sensors on them. So there's a lot of things you can do with RDM, and there are a lot of new devices coming out that have RDM capability, like not data splitters, but network switches and handheld tools. Like Doug Fleener's got the RAD, the remote address device, and there's a couple of other handheld tools out there that allow you to do some of this stuff. And I have a video that I shot of, well, if I can find my clicker. Oh, here it is. Let's see.
I got several fixtures, and this just isn't going to work for the show. So the old way, get out the ladder, climb up there, and change the addresses. But now we can do this all with RDM. So the first device that we have, manufactured by Doug Fleener, is called the RAD, Remote Address Device. So like we said earlier, it's all a matter of discovery first. So we're going to go out there and go, who's the first fixture? So our source 4 luster comes up first, and most fixtures, when you're doing discovery, will give you some visual indication of who they are. So the first fixture that we're playing with was that one flashing. We want to see where the next one is. Press the next button. The source 4 power with the dimmer turns on. Here's the next one. And then the Mac Aura comes to life and turns on in red. So now you know exactly which fixture in the rig. There can be 200 lights up there, and all you got to do is step through and find that fixture that you want to work with when you're there. So we're going to go back to our par and go, I want that on DMX2 now. Take the button, set it to 2, and now its DMX will be at 2. So we'll come back. First par is on 1. Well, let me guess, it's still in discovery mode. So my first fixture is on 1. my second fixture's on 2. Never had got on a ladder, go read the manual or anything like that. Okay, so that's the basics. This is a great little handy tool just for going through and setting addresses on the rig.
Now what, when you discover, you're sending out the query that says who's there, right?
Correct.
What's preventing all 4 or all the fixtures on your rig from sending back the message, here I am at the same time?
Each fixture has a unique serial number to it. The first part of the serial number identifies the manufacturer. The second part of the serial number is unique to that fixture.
Okay.
And basically the message goes out, the first one that comes back, and the device ignores all the messages. So then you hit the next button, it basically goes, who's next out there, the next one comes back. But like we said earlier, RDM can do a lot more. So great handy tool for addressing, setting up your rig, but I want to do more than that. I want to know what's going on with my rig. Unfortunately, glasses on. So there's other manufacturers with test equipment out there that allows you to read all sorts of parameters back. This one is manufactured by Goddard Design, and we're going to go down to the RDM controller display. So same thing, this controller doesn't know who's out there. So the first thing when you go in is you want to discover devices. So we're going to tell it to go out there and discover new. And those that are up close, you can watch the display, and it's actually going through all the possible addresses that are out there right now to find all the equipment that's on the network. And it's going to come back, so far it's found 1, and it's an ET device. It's a device manufactured by ETC. It's now found 3, and shortly it should.
So I was using my iPhone to film that. I forgot to charge it, and the battery died mid-film, mid-shoot. So RDM, not only does it save time, but it's also great from a safety standpoint. I'll give you an example. We were in a arena, I don't know, a couple months ago, and the catwalk was 120 feet from the floor. The trim height was 60 feet. So we had truss that virtually ringed the arena, all the way around the arena. And the first day after load-in, we set everything up, and the programmer came in, and he's sitting down, and the call comes over the radio. He's like, "Oh, guys, I'm really sorry, but I gave you the wrong address settings for all of the strobes, or whatever. Can you change them?" Okay, we had, I don't know, like probably 24 around various locations, various different trusses. Now our climber was in the catwalk, and she loves to climb. She loves to, she'll drop a rope ladder down, climb down. She's got her safety harness on, then she'll walk the truss with the safety cable. Loves to do that. She spent the next 2 days climbing down to the trusses, walking the truss. She'd lean over the side of the truss and change the, she'd have to get to the menu setting, change the DMX addresses on one fixture. And then she'd have to go to the next one and the next one. Then, she'd reach the end of the truss, so she'd have to climb back up, move the rope ladder over, go down, it took her 2 full days to do this, She loved it. And they were talking over the radio, and somebody said, it's too bad we don't have RDM. And her comment was, but then I'd be out of a job. And I wouldn't get to climb. Well, not really, because her job would change. So instead of climbing down the truss, she might be up there in the catwalk on a laptop or on a tablet or on a phone, changing the DMX address or the universe. So it's not like it's going to displace any jobs. But how much safer would it be if you could stay in one position instead of having to climb down to the truss? Unfortunately, people do fall out of catwalks and out of trusses, but if you're very careful, you can avoid that. But even some of the best riggers have taken falls or nearly fallen. So it's, from a safety standpoint, it's a good idea as well. So that kind of gives you a rough idea of what DMX does, and you will start to see it out in the field, and you will start using it when you when you have access to the right tools and you understand the kind of power that it has and the kinds of things that it can do. So, excuse me. This is a screen capture of an RDM device that kind of gives you another idea of what's going on here. So you set up your rig, you plug everything, you turn it on, and then you go out and you discover the entire rig, just like Bill did on the video. And in this case, it'll capture every RDM device has a unique identifier. It's kind of like an electronic serial number. And it'll report back and say, this is my UID, or my unique identifier. You can see it's a very long number, and these are hexadecimal numbers, base 16. And so that's actually a 32-bit number. And so every one is different for every RDM device. And then it'll tell you the source, where, the source would be the controller, and then the universe that it's on, the port number that it's coming out of the controller, the model number of that device, the manufacturer's name, and then you can type in a text label. You can label it. You can call it, these are all of my platinum beam fixtures, or whatever they are. The DMX address, and then the category. So this would be like a fixture, or it could be a controller, or it could be a fog machine, whatever the category it falls under. The location, so you could put in, this one is stage right, this one's stage left, this one's downstage, this one's upstage. You can label all these things. And there's more. There's more stuff over there that falls off the screen. And then if you look at a particular fixture, you can see the UID, the manufacturer, the model, the software version, how many sensors it has. You know, a sensor could be a voltage detector, a temperature sensor, current sensor, all those things. Sub-devices, the DMX address, the personality or the mode that it's in, and a whole bunch of other stuff. The identify state, is it flashing right now? Is it identifying itself so you can tell where it is in the rig? In this case, no, it's off. How many hours has the device been turned on? 36 hours. How many hours on the lamp? 30 hours. How many times has it been cycled on and off? 18 times. Is the lamp on or off? It's off because it has a light sensor, and more stuff like that. So all of this stuff now can be reported back from the fixtures back to the control system. So that can come in very handy. So that's RDM. RDM works with DMX. So it lives on the controller. The controller outputs DMX. And then when the operator pushes a button, it asks the device, what's your DMX address? It stops outputting DMX, and it'll send out one RDM packet that asks the question, and it waits for a response. When it gets a response, then it goes back to DMX, or if it doesn't get a response, it waits a certain amount of time, and then it goes back to DMX again. So these RDM commands are interspersed in between the DMX packets. That's how RDM works. So it kind of rides on top of, it uses the same cables as DMX, same connectors, the same controllers, the same network switches, all that stuff is the same for RDM as for DMX, but it's in between all of the DMX traffic that the RDM works. Now, streaming ACN is an industry standard that came out in the same time, 2008. And this is a consensus standard for transmitting multiple universes of DMX over an Ethernet network. So it uses Cat5 cables, and it can send many universes of DMX over a single Cat5 cable or a single Ethernet cable. That's the advantage. So instead of running a whole bunch of home runs, then you can run one Cat5 cable and run a bunch of universes. Yes?
Is there a limit to how many?
Yes, there are limits. The question is there a limit to how many universes you can send over a Cat5 cable? It depends on the network, because there's different flavors of Ethernet. You have the original Ethernet was 100 megabits, 10 megabits per second. And then later on, they came out with what they call fast Ethernet, which is 100 megabits per second. And then later on, 1,000 megabits per second, which is a gigabit per second. That's called a gigabit network. And then now we have 40 gigabit network, and they're working on 100 gigabit.
So it just depends on the bit rate of the...
It depends on the speed of the network, and that's dependent on the hardware. So for example, you can buy a gigabit switch, but you also have to have a gigabit network interface card in the controller if it's, you know, so the network's only as fast as the slowest component of the network. So if everything is gigabit, that means you can run, in theory, 4,000 universes of DMX on a single Cat5 cable. Now in practice, there's a difference between the baud rate, the rate of transmission, and the throughput of the network, because sometimes every device like a switch or a router has to get the packet and look at it and read it and figure out where to send it. That takes time. So the amount of traffic that gets through, that's called the throughput, is about half of the baud rate. So that's why I say in theory 4,000 universes, but in practice it's closer to 2,000 universes. Still, 2,000 universes, that's pretty good. Now, right now we think that's a huge number of universes, but 10 years ago we thought 30 universes was a huge number of universes, you know, but it's not uncommon today for shows to come through town that have 32, 34, 36 universes of DMX. So that's with the gigabit network. With fast Ethernet, which is 100 gigabit per second, which is much more common, 100 megabit per second, that's 20 universes of DMX. Now, with ArtNet, they have a new version of ArtNet that's a little bit more efficient, so I think they can get 24 universes of DMX with ArtNet 3 now. So, or no, ArtNet 2. With ArtNet 3, it's 200 universes. 2,000, yeah, 2,000. So, anyway, yeah, question?
So like ArtNet, ETCNet, and RDM, is RDM, you might have explained this already, but is it running on the same exact network as ETCNet or? Okay,
so ETCNet is a way of transporting DMX using an Ethernet network. And ETCNet will also transport RDM. Streaming ACN does exactly the same thing as ETCNet, except streaming ACN cannot do RDM. Streaming ACN only does DMX, not RDM. They're now working on streaming or RDM net. So this is a new protocol under development. When it's finished, you can run streaming ACN and RDM net together. Now that allows you to transmit DMX and RDM on the same Ethernet network.
So right now it's certainly separate.
Right. Yeah. So, but that's coming. That's coming. So you can see why understanding Ethernet now is getting to be more important in our industry. So that means you need to understand IP addresses, and you need to understand subnet masks. If you go to configure your computer, you'll find like for example on a Mac, and it's the same on a PC except different syntax. I will go into network and I can connect. If you click on advanced, then you click on TCP/IP, you will see, so whichever, let's see if I can do this, TCP/IP. Okay, so now, right now I'm set to let the network give me my IP address. So there are certain times when you want to manually configure your own IP address. So for example, if you've ever used the iPad controller called Luminaire, you need to set the IP address. Or I'll give you another example. I was doing a show where I was programming a media server, and a media server is a computer that has software running on it. And you have to be on the same network as the console if you want the console to trigger the media server. That means that you have to set your IP address to a certain number in order to communicate with the console. So you go to the console, you look at the IP address, and then you come back to the media server and you open up this window, and then you click on manually configure your own IP address. And then if you select that, then what will happen is it'll give you these numbers right here. Now an IP address is in what's called quad dotted notation, quad dotted decimal notation. So quad, notice there's 4 numbers here, and they're separated by a dot, and then the numbers that are in there are decimal numbers that range between 0 and 255. So I can go in and manually configure my IP address. Now there are certain numbers that you will see over and over and over again. If you go home on your computer at home, and if you're on a Wi-Fi network and you open up this window and look at your IP address, what you'll find is it's going to start with 192.168.something.something. Does that sound familiar to anybody? The reason is that is what's called a non-routable address. You'll see this number for the kinds of networks that we do, 192.168.something.something. Now, if you configure your IP address to this, like say 0.10, and then you try to get on the internet, it won't work, because this is what's called a non-routable address. It's for private networks. These are for networks that are not going onto the internet. And so there's a certain range of numbers that are reserved for the kinds of networks that we build with lighting consoles. And they start with 192.168.something.something. Or if you're using ArtNet, it will be 10.something.something.something. Or in the early version of ArtNet, it was 2.something.something.something. So you have to know how to set up your IP address. And a lot of times the user manual will tell you, set your IP address to this number. And then they'll give you a range of numbers. They'll say, set it to 10.0.0. Any number between 1 and 255. So you configure your IP address. And then when you do that, then you have to come in here and set up your subnet mask. And again, the manual will tell you what the subnet mask should be. Most of the time, the subnet mask is going to be 255.255.255. So wait, no, that's not right. 255.255. It could be 0.0, or it could be 255.0.0.0. So this would be for the one of them is for the older version of ArtNet, and one's for the newer version of ArtNet. And if the settings are not exactly the way they tell you in the manual, it's not going to work. So get used to the idea of manually configuring your own IP address. So this is something that you can look for on your computer when you get home. Whether it's a Mac or PC, there's a way to do that. And more of the gear that we use depends on your ability to set up a network and connect all these devices together for them to run. Media servers, consoles, what else has its own IP address? Sorry?
Sound.
Yeah. Yeah. So Dante is the audio version of this. So with Dante, you can have an amplifier that is on the network, and it's got to have its own IP address because it's got to know where to send the information to or get the information from. The audio mixer can be on Dante. Video projectors can be on the network now, and more and more things that we use are going to be on the network. And now with the Internet of Things, have you heard that term? Every device will have an IP address. So for example, you could have let's see. Well, I don't know. I can't think of an example, but a pen could have its own IP address. A camera. Yeah, there you go. Camera. What else? A what? Coffee maker, a watch. Yeah, all these things are going to have their own IP addresses. So get used to the idea of configuring IP addresses. All right, we have about 15 or 20 minutes left, and we've pretty much gone through all the material. So if you have any questions, there's a couple of things that we still want to do. Oh, I didn't get the surveys done. Okay. I usually pass out these evaluations. So I'm going to ask you before you go, not yet, but in a little while, if you can just take a blank sheet of paper and write your evaluation of the class. Okay, let me know what you liked about it, what you didn't like, how you think it could be improved. And also, I have a newsletter that I send out, and I always try to include useful information. I don't want to stuff your inboxes with junk mail, but I do try to write short, informative articles. Like whenever I come across a situation, for example, the guy that had trouble with his DMX, and so I'll probably write a short article about why terminating the data run could have helped him in this situation. You know, and it'll be a quick, easy read. Hopefully it's a little bit entertaining, you know, maybe even funny sometimes. So I always kind of put that kind of stuff in my newsletter. And then there's various resources like DVDs and books and that kind of stuff that go in the newsletter as well. So if you want to receive the newsletter, then when you write up your comments, give me your email address, and I will put you on the mailing list. If you don't want to receive the newsletter, it's okay. I won't be offended. I won't hold it against you. I understand. I get a lot of email too. I can't keep up with it anymore. So I don't want to send you email if you don't want to receive it. Or even if you want to try it out. If you don't like it, you can always unsubscribe. So it's up to you. Did we get any certificates printed? Do we have? Okay. All right. So he's going to go check on. I'm trying to get a certificate of attendance for all of you. Hopefully before you leave today. Okay. So, you know, we've covered a very broad gamut of topics today. And if you get nothing else out of this class, I would really like for you to at least understand enough about electricity to work safely. And so what that means to me is that the next time you're at a show, see if you can identify what is a hazard, what might be a potential hazard. And that would be missing grounds, missing grounding terminal, grounding lug, things like, you know, sometimes you see people disconnecting cables before they make sure everything is off. Notice where people are standing. Are they standing on wet grass? Are they standing on a concrete floor? Maybe the floor has a puddle of water on it and they're standing in that. Are your circuits on GFCI protection? If you're doing a show outside, look around. See if you see any GFCIs on the show. You know, they should be on GFCI protection if there's a possibility of water or moisture. Or I would love to start seeing GFCIs on backline gear, on stages. Anytime somebody picks up a guitar and that's plugged into an amplifier, electric guitar, it would be great if that guitar amplifier had a GFCI plugged into it. The same with the PA system when he grabs the microphone. Or even just the guitar amp itself, that would help a lot. So if you understand how electricity works, if you understand what a hazard is, if you understand how to mitigate the hazards, you know you should be wearing certain type of personal protective equipment, meaning gloves, sometimes rubber gloves, sometimes leather gloves, sometimes cotton gloves are okay. Shoes with rubber soles to insulate you from the earth. Head protection if there's anybody in the steel overhead. If there's a possibility something could accidentally fall off. In certain cases, eye protection. If you're doing a live tie-in, there's a possibility of arc flash. You should have safety glasses on because you don't want the shrapnel. When it arc flashes, it creates a ball of fire and it melts things and they tend to explode. So you get this blast with molten metal flying at you. So eye protection is important. Protect your eyes. So those are the basic things. Your meter. You should have a Category 3 meter. Go out, save up some money. Get a true RMS reading meter with at least a Category 3. And you can find them for, I have one I paid $125 for. It's a great voltmeter. It's made by Fluke. It's a good brand. When you buy a clamp meter, make sure that it's at least Category 3. Look at those contact voltage testers. They're very inexpensive. I think they're somewhere in the range of about $24, $25. And if you just carry one of those around, that's a great tool to have. You can tell at a glance if something has contact voltage on it. And remember to meter all of the pieces of metal to make sure you have continuity. So you'll go up to a piece of truss, check for continuity to the building steel, or the chassis of an amplifier to the building steel. Start looking into those bonding connections. Make sure that you have the proper bonding, the proper grounding. And lastly, the most important tool you can have is knowledge. And remember, the technology is changing every day. It's changing. It's important that you keep up. So whatever you do, read as much as you can on the subject. Talk to people. There's lots of great forums. There's lots of great books out there. There's lots of resources. What we've done today is that we've sown some seeds. And what do you need for those seeds to bear fruit? You have to nurture them. You have to care for them. You have to give them the right environment. You have to water them. And you have to look after them to make sure that they grow and that they produce fruit. And if you care about yourself and your colleagues, the people around you, then that's what you'll do. And if there's ever anything that I can do to help out, let me know. I want to thank you all for coming here. I hope you've learned something, and I hope we can do this again sometime, okay? So thank you all very much. And please fill out those comments and turn them in. You can make them anonymous if you want, and just leave them up here at the front. I'd love to have them. Thank you all very much. Appreciate it.